So this lesson we will be going over parallel and perpendicular lines, focusing first on parallel. And we're going to be writing the equations. So based off of what we know about y equals mx plus b, we'll be writing their equations for parallel lines and later for perpendicular lines. So parallel lines and perpendicular lines, both, it's going to help you with a lot of concepts later. When we get to, if you take calculus, you'll get to derivatives. And tangent lines, we'll talk about that a little bit in this class. And then also we're going to be using all of this when we get into our quadrilaterals unit to figure out what type of quadrilateral something is based off of parallel and perpendicular lines. So when you can write the equation, you know you get it. So first, slope formula. Slope is y2 minus y1 over x2 minus x1. So sometimes this is just written as the difference in y's and the difference in x. Sometimes it actually, you'll see this symbol. It's the change in y over the change in x. Eventually you'll see that. For right now, it's okay if you just think of it as y2 minus y1 over x2 minus x1. Then we got slope-intercept form, probably the most famous equation of a line, y equals mx plus b. M is the slope, and B is the y-intercept. So another equation of the line, pretty commonly used, we'll use this today, is point slope. Point slope form. M is the slope, still, just like y equals mx plus b. M is slope. But what's nice about it is you don't have to know the y-intercept. You could just know any point. x1, y1 is just a point on the line. x1, comma, y1 is just any point that it passes through. That x1, y1 could be the same x1, y1 that you use in your slope formula. The y2 minus y1 over x2 minus x1 could be the same x1, y1. So we're going to start just by finding some slopes. When they give you 2 points, you have to use the slope formula. So here's xy. XY, 1, 1, 2, 2. We're going to plug it in and find the slope. So y2 minus y1 over x2 minus x1. And just simplify that out. Minus negative is plus, that's where we get 6. And then negative 3 minus 2 is negative 5. So that is the slope. That means down 6 over 5 to the right. And y equals mx plus b. There's your slope, 5 halves. Means up 5 over 2, because it's always rise over run. So to find the slope, this is called standard form. To get the slope, I would just convert it to slope-intercept, which means we want to get y by itself. So subtract 6x from both sides. And then still trying to get y by itself. Now we're going to divide everything by negative 2. So that means that our slope is the coefficient in front of the x, 3. Slope is 3. And when you have the graph, you're just going to find some points that are perfectly crossed through your coordinates that you want to use. So there's a good point. And there's a good point. There's more than one you could have, or there's more than just those two. You could have also chose maybe that or that one. Now, slope is sometimes called just rise over run. But you're looking for your change in your y and your change in your x. So no matter how you do it, this one goes down 3 over 1, down 3 over 1, down 3 over 1. So your y's first, that's the up and down. So down 3 means negative 3. And then over 1 would just be over 1, like a fraction. So the slope is just negative 3. So now we're going to practice writing the equation of a line if we know the slope and we know a point. Since we know the slope and a point, it would make sense to use slope form, which is y minus y1 equals m x minus x1. So then from everything that we're given in this sentence, we know the slope, that's m. So we're going to put that 1/2 right there. And we know this point. This is x and y. This is x1, y1. So this y1, we're going to put right there with y1. So it's y minus y1. Then we do x minus x1, so minus 6. Now, that is an equation. That's the equation that passes through that point with the slope of 1/2. We're going to do a little bit of algebra just to convert it into slope-intercept form, though. So to convert from point slope to slope-intercept form, you have to distribute the 1/2 times x, and then 1/2 times negative 6, and then finish it off by adding the 1 over to get y by itself. And there's slope-intercept form for that line. So we're going to graph two lines. So this first equation, y equals 3x plus 5. We know that that's the slope. We know that that's the y-intercept. So we're going to start with the y-intercept of 5. And then we know the slope is 3, which means it's going to go up 3 over 1. So I'll be right about there. It's kind of off the graph, though. Now, we need some more points, because that's not a very good, especially since we're not even on the actual graph up here. Let's get some more points. So instead of going up 3 over 1 to the right, we're going to continue that pattern the other way. So if we're working backwards, you're going down 3 and left 1. Down 3 and left 1. You can see that all makes the same line right there. And there's our line. We're going to do the same thing with this equation once we have it in slope-intercept form. So the first thing we're going to do is get slope-intercept form. We're going to solve for y. So we're going to subtract the 6x. and then we're going to divide by -2. We get y by itself. Negative over negative is +3. And then 4 divided by -2 is -2. We can graph the same way. We're going to start with the y-intercept of -2. So we're going to put our first point on the y-axis at -2. And then the slope is 3, which means it goes up 3 over 1. Up 3 over 1. And if we wanted another point to the other side, you could go down 3, left 1. That would work too. So there's our 2 lines. So looking at these 2 lines, you could probably make a conclusion about them. Because this line that I did with the red points was going up 3 over 1, up 3 over 1. And so was the one with the blue points. Up 3, right 1, up 3, right 1. And also by looking at them, you probably can use a word to describe them, but they look like they are parallel. Because they are parallel. Now, the key that we're going to look at right here, though, is why are they parallel? They have that same slope. They can't touch each other if they're going up 3 and over 1 all at the same time and they're not touching each other to begin with. So since this had a slope of 3 and this has a slope of 3, they have the same slope, which means they can't pass through each other because they're not touching each other at the y-intercepts, and then they both go up 3 over 1, so they're going to stay the same distance apart. The definition of parallel lines is lines in the same place that never intersect and have no points in common. The rate of change must stay the same. The rate of change must stay the same. So when you think about it that way, rate of change, if rate of change is a lot like speed, for example, like the speed of a car. So if you have 2 cars that are going the exact same speed, or the same rate of change, and one of them's got a little bit of a head start because they're not starting in the same place, if you're in that back car, you're never going to be able to catch up because you're going the same speed. So that's kind of the same thing with lines. Lines will run parallel. They have the same rate of change. It's called the slope. And they start in different places. You can never catch up because they have the same rate of change. So here we've got a graph with a line on it and a point over here. If we are going to write the equation of a line that passes through that point and is parallel, we know parallel means they've got the same slope. So we're going to look at this first purple line and we're going to get what the slope of this purple line is. So there's one good point that it passes through. We need another good point that it passes through. Just like right there. So to get from one point to the other, it goes up 1 and over 3. That's your slope. Up 1 over 3. So from this point, we're going to do the same thing. We're going to go up 1 over 3. Up 1 over 3. We can continue it out as much as we want. And then you can draw the line. You can see that they're parallel. Now, that wasn't what the question said, though. It didn't say just draw the line. It said write the equation. But since we drew it out, we can write this equation pretty easily because we know it's going to be y equals mx plus b. We know the slope is m, which is going to be 1/3. And we know that b is the y-intercept. So if you look at where we graph that line, the y-intercept is right there at 2. There's your equation. So you can do that same process without the graph. This time we use the graph kind of to help us out. But you can do that without the graph because you know m, and you actually know a point that it's going to pass through. You know a point that it has to pass through right here, -3, 1. Which means we know x1, y1, and m. We can use point slope form just like we did a couple examples ago and write the equation out without using the graph. If you know the point and the slope, you can use point slope form just like we did a couple of examples ago. But then you would distribute and solve it out. So let's try that. So since we are looking for a parallel line, that means it's going to have the same slope. Parallel means it's going to have the same slope. So we're looking at this equation. We need to know what the slope is. So to figure out the slope, we're going to convert it to slope-intercept form. And then we're trying to get y by itself, so we're going to divide by 3. -9 over 3 is -3, plus 8/3, we can just leave it as a fraction. Now, the only thing that matters from that is the slope. That's the only piece of that equation that we care about. And then we're going to take that, we're going to plug everything we know into point slope formula. So now we know the slope is -3. And then we know x1 and y1 because x1 is right here, y1 is right there. So that's minus -1, and then minus -4. So now we can simplify this out. Minus negative turns to plus. Minus negative turns to plus again. And to get it into slope-intercept form, you're going to distribute. And then finish it off by getting the 4 onto the other side, so -4. So it's got the same slope, different y-intercept, because that's what it means to be parallel.